DNS runs on a partnership between two distinct characters. The recursive resolver is a friendly librarian who hunts down answers on behalf of any client that asks, doing all the legwork of following referrals across the internet. The authoritative server is a stoic archivist guarding a vault for one zone, dispensing the definitive truth with no investigation required. Every DNS record carries a time-to-live value, a countdown number measured in whole seconds that tells recursive resolvers how long they may keep serving the cached answer before they must ask the authority again. Think of it as an hourglass glued to every record. When the sand runs out, the resolver is obligated to return for a fresh answer. This is why TTLs matter for changes. When you update a record, every recursive resolver already holding the old answer will keep serving it until its cached TTL expires. A 300-second TTL means a change can take up to 5 minutes to fully propagate across all caches, and propagation is never instant. The old answer lives on in caches until each hourglass runs dry. Negative responses carry TTLs too. When a name does not exist, a next domain, or when a record exists but has no requested type, no data, the authority returns the SLA minimum field, and resolvers cache that emptiness for the specified seconds. This prevents the network from being hammered by repeated queries for misspelled or non-existent names. Name chains accumulate TTLs as the lookup hops from name to name. When a name at the apex redirects the query to another name, the resolver follows it, and the final A record is cached with the TTL of whichever answer was observed last. The takeaway mental model is simple. TTL is the question, how stale am I allowed to be? And every cache answers it independently until its hourglass empties. Before we begin our DNS exploration, we clear the terminal to start with a clean workspace. A blank canvas ensures that the output of our queries is easy to read and analyze. With the stage set, we are ready to dig into DNS. The command digexample.com queries the authoritative DNS system for the IPv4A record of example.com. By piping the output through grep a2 answer, we isolate just the answer section with 2 lines of context, cutting away all the boilerplate. The result shows example.com resolving to 93.184.216.34 with a TTL of 86,400 seconds, the full default lifetime for this record. Now we run the same query a second time, filtered the same way. Notice the TTL value has dropped from 86,400 to 86,395. Exactly 5 seconds less than the first query. This is TTL countdown in action. Every resolver caches the record and decrements the remaining lifetime with each passing second. By observing TTLs across multiple queries, you can see caching behavior happening in real time. Finally, we use dig plus trace example.com to walk the full delegation path from the root name servers down to the authoritative server for example.com. Piping through tail -10 keeps the output focused on the final hop. This shows you the chain of trust. Root, TLD, and authoritative server, all collaborating to return the answer.